Hello everyone, welcome to this video. Today we are going to discuss something very interesting and definitely beneficial for all of you. Let's get to the part 1. Today I want to answer the P23. Let's go step by step to answer these questions. Part 1. We assume that the first link is the bottleneck. This means that the transmission delay on this link is the dominant factor affecting packet arrival time. This is the time required to push a single packet of size L bits into the first link. Next, since both links have the same propagation delay, the time taken for a packet to travel from the server to the client is 2D prompt. Since packets are sent back to back, the first packet completely leaves the first link before the second packet starts being transmitted. Once the first packet reaches the second link, the second packet is still being transmitted on the first link. Thus, the inter-arrival time at the destination to the last bit of the second. Part 2. Now, we assume that the second link is the bottleneck, meaning its transmission rate R is greater than R. The first packet arrives at the input queue of the second link after. Conclusion: yes, the second packet will queue at the second link input queue. The second one. To prevent queuing, we must ensure that the second packet arrives at the second link only after the first packet has finished transmission on the second link. Conclusion: the server must wait at least L per hour seconds before sending the second packet to avoid queuing at the second. The next one I want to answer in section 1.4 R18. Let's start by outlining the given parameters. The packet length is 100 bytes which convert to 8,000 bytes. The distance the packet needs to travel in 2,500 kilometers, and the propagation speed is 2.5 meters per second, and the transmission rate is 2 Mbps, equivalent to 2 kali 10 pangkat 6 bits 6 per second. Sorry. To determine the total time it takes for the packet to travel across the link, we need to break it down into two components: propagation delay and transmission delay. Propagation delay refers to the time taken for a single byte to travel from the sender to the receiver. Transmission delay, on the other hand, is the time required to push all bytes of the packet onto the link. Let's calculate the propagation delay first. We must substitute our value, and now let's move on to the transmission delay. To generalize for any packet of length L over a link of distance D with propagation speeds and transmission rate R, we use the formula T total sama dengan D per S plus L per R. In conclusion, propagation delay depends on the distance and speed of transmission, while transmission delay depends on the packet size and transmission rate. The total delay is simply the sum of these two components. Understanding this delay is crucial for optimizing network performance and improving data transmission efficiently. Thank you for your attention.
What advantage does a circuit switch network have over a packet switch network? And what advantage does TDM have over FDM in a circuit switch network? There are 4 advantages that a circuit switch network has over a packet switch network, and the first one is that circuit switch network guarantees bandwidth and quality of service, because in a circuit switch network, a dedicated communication path is already established between the sender and the receiver for the communication and for the duration of the communication. This ensures a consistent and guaranteed bandwidth, which is very useful for applications that require stable and predictable performance, such as voice calls and video calls. The second advantage is low and consistent latency. Because the path is dedicated and there are already resources that are reserved, there will be minimal delay and also no congestion-related latency. This makes the circuit switch networks ideal for real-time communication. The third advantage is simple data transmission, because the data that is transmitted is in a continuous stream and doesn't need for packetization, addressing, or routing decisions. This simplicity can reduce overhead and processing requirements for the receiving end. And the last advantage is that there are no packet loss in a circuit switch network, because the connection is dedicated and there are already resources that are reserved. And then, the advantages of time division multiplexing over frequency division multiplexing in circuit switch networks. There are 5 advantages, and the first one is the efficient use of bandwidth. In time division multiplexing, it divides the available bandwidth into time slots, allowing users to share the same frequency by taking turns. This is more efficient than frequency divided multiplexing, which allocates a separate frequency band to each user, which can potentially leave unused gaps in the frequency. And the second advantage is that TDM does not require guard bands because it separates signals in the time domain, which leads to better utilization of the frequency and the available bandwidth. And the third advantage is the simpler hardware implementation, because TDM systems typically require simpler hardware compared to FDM, because they don't need the complex fillers to separate the frequency bands. This reduces costs and reduces the complexity in the infrastructure of the network. The fourth advantage is that TDM is better suited for digital signals because it can easily handle time-sliced digital data streams, while FDM is more commonly used for analog signals and also needs more additional modulation and demodulation steps for digital communication. And the last advantage is scalability, because TDM can be more easily scaled to accommodate additional users by just adding more time slots, whereas FDM requires allocating additional frequency bands, which may be limited by the available spectrum that you already have. Problem 25. Suppose two hosts, A and B, are separated by 20,000 kilometers and are connected by a direct link of R equals 5 Mbps. Suppose the propagation speed over the link is 2.5 times 10 to the power of 8 meters per second. The first question is calculate the bandwidth delay product, which is R times D propagation. To solve that, first we need to calculate the propagation delay, which we can do it by dividing the distance by the propagation speed, which is the distance will be 20 kilometers or 20 million meters divided by the propagation speed, which is 2.5 times 10 to the power of 8 meters per second. And when you divide the distance by the propagation speed, you get 0.08 seconds. And now, to calculate the bandwidth delay product, you need to times 5 megabits per second times that 0.08 seconds, which is the propagation delay. So when you do that, 5 megabits per second times the propagation delay, you get 0.4 megabytes or 400,000 megabits. The second question is the maximum number of bits in the link at any given time. To answer that, we need to know that the maximum number of bits in the link at any given time is the same as the bandwidth delay product, which we already solved in the first question, which is 400,000 bits. The third question, interpretation of the bandwidth delay product. The bandwidth delay product represents the maximum amount of data that can be in transit on the link at any given time. It's the product of the link's capacity or bandwidth and the time it takes for a signal to propagate from one end to the other end, or the propagation delay. So the fourth problem, the width of a bit in the link. To find the width of a bit in the link, we need to use the formula of the propagation speed divided by the transmission rate, which we already know, so all we need to do is calculate 2.5 times 10 to the power of 8 meters per second divided by 5 times 10 to the power of 6 bits per second. And when you calculate that, you get 50 meters per bit. And a standard football field is about 100 meters long, so a bit width of 50 meters is about half the length of a football field. And then the fifth problem, derive a general expression for the width of a bit in terms of the propagation speed as the transmission rate R and the length of the link M. The general expression for the width of a bit in terms of propagation speed as the transmission rate R and the length of the link M is, so the formula is the width of a bit equals to propagation speed divided by the transmission rate. That's the formula. Thank you.
The word protocol is often used to describe diplomatic relations. How does Wikipedia describe diplomatic protocols? Wikipedia describes diplomatic protocol as a set of formal rules and procedures that govern diplomatic interaction between states, organizations, and officials. It includes guidelines on etiquette, precedents, formal communication, and ceremonial practices to ensure smooth international relations. Diplomatic protocol helps maintain order, respect, and professionalism in diplomatic engagement. Suppose you would like to urgently deliver 50 terabyte data from Boston to Los Angeles. You have available a 100 Mbps dedicated link for the transfer. Would you prefer to transmit the data via this link or instead use FedEx overnight delivery? To determine whether transmitting 50 terabytes over a 100 Mbps link is preferable to FedEx overnight delivery, let's calculate the transfer time. Step 1. Convert 50 terabyte to bits. Step 2, calculate transmission time. And then step 3 is compare with FedEx. FedEx overnight delivery typical takes 1 day. 56.3 days is significantly longer than overnight delivery. Conclusion is using FedEx overnight is the better choices for urgent delivery, as it takes only 1 day, whereas data transfer over the 100 Mbps link would take around 56 days. What is self-replicating malware? Self-replicating malware is a type of malicious software that can copy itself and spread to other systems without user intervention. The two main types are worm. This propagates through networks by exploiting vulnerabilities in software or by spreading through email, attachment, USB driver, or infect a website. They do not require a host file to spread. And the second one is virus. These attach themselves to legitimate file or program and spread when the infected file is executed. Unlike worms, viruses require user action to replicate. Self-replicating malware can use widespread damage by consuming system resources, stealing data, or enabling future cyber attacks. Thank you.
This for section 1.2. What are some of the physical media that Ethernet can run over? The first one is twisted pair copper cable. Example is CAT5E, CAT6, and CAT7. The second one is fiber optic cable. Examples are single mode or multi-mode fiber. The third one is coaxial cable, less common in the modern Ethernet. That's it. For the question P22, these are the summary. Probability of successful packet reception is 1 minus P to the power of n. For the average number of retransmission is 1 over 1 minus P to the power of n. These formulas allow you to calculate the likelihood of a packet being successfully received and the expected number of retransmission needed based on the number of links and the packet loss probability per link. That's it.
Okay, using only one path. Each path K consists of n links with transmission rate RK1, RK2, and RKn. Since data must pass through all the links in the path, the bottleneck link, an example like the link with the lowest transmission rate, determines the maximum throughput for that path. For a given path K, the throughput is, here's the result. Thus, if the server can only use one path, the best option is to select the path with the highest bottleneck capacity. And here's the result. Okay, next, the second case, using all M path. If the server can use all M path simultaneously, the total throughput is the sum of the throughput of each path. And here's the result. The final answer is if the server can only use one path. So here's the result, and the next one, or the last one, if the server can use all M path, here's the final answer. Okay, what are the 5 layers in the Internet protocol stack, and what are the principal responsibilities of each of these layers? So, the 5 layers in the Internet protocol stack and their principal responsibilities are: the first one in application layer, provides network service to application like web browsing, email, file transfer, example like HTTP, SMTP, FTP, DNS. And the second one is transport layer, ensure reliable and unreliable data delivery between applications. Protocol TCP, reliable connection oriented, and UDP, unreliable connectionless. And the third one is network layer. Network layer handles routing of packets between devices across different networks. Protocol IP, Internet Protocol, ICMP, and ARP. And the fourth is link layer, manage data transfer between directly connected network devices. Responsible for MAC addressing, error detection, and access control. Example, Ethernet, Wi-Fi, PPP. And the last one is physical layer, handles transmission of raw bits over a physical medium, cables, radio wave, defines electrical and mechanical properties of connections. Each layer works together to facilitate communication across the internet. So that's all. Thank you.